Hello everyone. I am Janki Varot, Assistant Professor of Computer Engineering Department, Aditya Silverok Institute of Technology. Today I am going to introduce memory management in this video lecture. Let's see the agenda of the video. This is the basic outline of this lecture. We are going to introduce the memory. What is main memory? Then we'll see the difference between logical address and physical address. After that, we'll see memory management and its functionalities. And later on, in the last topic, we'll discuss memory allocation. So let us start with the introduction of the memory. Okay, now what is memory? Memory is a second major component in a computer system after processor, right? Now, memory system of a computer is constructed as a hierarchy of the layer containing registers, cache memory, hard disk, and magnetic taps. These layers are differing from one another by their access, speed, storage capacity, and cost. Disks are basically used to store all kind of information including process code, all information to store on a disk in a various file. So it is more time consuming to access such information from the disk because disks are lower speed device as compared to processor, right? The solution is that we need to fetch the information in a main memory before using it to get the to accessing the speed of the main memory before using it. Now, processors access this information from the main memory. These raises various issues like memory allocation, memory deallocation, protection, sharing, etc. So that mm, memory management is needed. Now, first of all, we'll see main memory. Everyone has heard about memory, main memory, right? So, it is also known as a physical memory. It comes in a form of chips internally in computer system, right? Now, main memory is the middle layer in a memory hierarchy of the computer system. It is slower, cheaper compared to cache memory, while faster and costly compared to disk. It is a slower and a cheaper as compared to cache memory, right? But it is faster and costly as compared to disk. Main memory generally consists of random access memory. Now, it is volatile. What is volatile? It means that it need electric power in order to maintain its information. Entire main memory consider as a entire main memory considered as a sequential list of bytes. Each byte has an address and that is used to locate it. This address is called the physical address. Means physical memory will have physical address, right? And each byte has an address in registers. Now, the address for most computer systems start from the 0 up to its sequential byte size, right? Now, first of all, we'll see the difference between logical address and physical address. Now, first of all, we'll see what is logical address and what is physical address. We all know the process. The process is having an address space and it can be considered as a sequential list of bytes, right? Now, each byte has an address that is used to locate where the process is. And this address is called logical address. Same as in a physical address, we can say that entire physical memory can be considered as a sequential list of bytes, right? and each byte is having an address that is used to locate it, and this address is called physical address. Now, this is generally the logical address is generated by CPU. Means CPU determines location of each instruction and data in process address space, where physical address is generated by main memory. Logical address space is a set of all logical address that can be referenced by that can be referenced by the process, whereas physical address space is a set of physical address occupied by a process in a main memory during its execution. The fourth one is logical address space is a set of all logical address, right? And which is referred by the process only, where physical address space is a set of physical address which is occupied by a process in a main memory during the execution time. Now, logical address, we can say that process can read and write address of its own logical address space, but process can only read or write its own physical address only. It can't be able to read or write another process physical address. Okay. Next is address in a logical address space is start from 0 and goes up to the maximum value based on the size of a process, right? Whereas physical address space may or may not be continuous based upon the memory location method. Why so? Because in a physical memory, you can say that in a physical address, physical memory, uh, there it is not fixed that we need to store the data in a continuous manner, right? When and where some process leave the address space, we need to reutilize so that there will be no fixed sequential allocation. Okay, now we'll see what is memory management. What is memory manager? Memory management unit is a part of operating system that deals with main memory, right? It is nothing but a part of operating system which deals with the main memory, and memory manager, it is having a main goal to efficiently utilize the main memory among various simultaneously executing process, right? We need to utilize the main memory where we need to allocate and deallocate the space. Now we'll see the functionalities of the main memory unit. Now, here we can see that there are operations, 6 operations are there. It performs memory unit. Memory unit performs the first operation is fetch. For what? It should determine when to move information from disk to main memory, right? First of all, from disk, when to move, we need information from disk to main memory. That information need to fetch by MMU, right? Second is placement. Now, it should determine where to fetch information, where to put fetched information in memory, right? Why? Which means that memory is allocated for fetch information. Now, the third one is replacement. If memory is required, if memory is required, process needs more memory, right? Instead of available memory, it requires more memory. So where if memory is required but not available, it need to determine which information to remove from memory. So we need to set here a priority, right? Based on the priority, we can remove any of process which is having a low priority, and we can replace it with the current process for the execution. Okay. Next is sharing. Now it need to allow more than one process to share a piece of memory. It is obvious because there is no fixed place, there is no fixed memory slot which is permanently allotted to any process. Right now, address translation, it is the most important point. Why? Because we need to translate logical address to the physical address. Why? Which process need to execute where in which physical address. So we need to translate logical address to the physical address, right? And it is solely responsibility of MMU. The last operation is protection. It protects the memory against an unauthorized request for access. One process should not have access to the unauthorized information of the another process. Now we'll see memory allocation. Memory allocation, we can say that how we can allocate the memory. There are different ways to allocate the memory. Memory should be allocated in a various processes and file as per the requirement. When there is no need allocated memory, it should be free so that we can utilize the free slot. Memory has a limited capacity compared to disk, as we have seen earlier that compared to disk it is having a limited capacity, so that memory should be allocated very carefully among all the processes which are running simultaneously. Now, while allocating memory, we need to fulfill two goals, mainly two goals, that is a high utilization and high concurrency. High utilization means we need to try maximum possible memory should be utilized, right? And the second point is no any single process of memory should be wasted. Like that, we need to allocate memory to the process. Now, high concurrency. Maximum process should be in main memory. Concurrency, any in concurrent manner, many concurrent program, many processes are running in a parallel mode, and all the process must be try to execute in a main memory so that we can have the smooth throughput, right? When more and more process in a memory, when more and more process in a memory, CPU will remain busy. So most of time in execution one of the process, CPU will remain busy and it will result in good throughput, right? We are not wasting the CPU cycles. We are keeping CPU busy. How we can utilize the main memory. Now next topic is main memory allocation, how we can allocate different types of memory in which we can allocate the memory, that we will see in a next video lecture, right? So in this lecture what we have discussed is what is memory, introduction of the memory. After that we'll see that what is physical memory, that is a main memory, right? After that we have discussed about the logical address and a physical address, whereas logical address is the space which is considered in a process, whereas physical address is the space where the process is going to execute it, right? Now, we have seen what is memory management unit. After that, we have seen the functionality of MMU, and at last, brief introduction of memory allocation. Thank you.